Hi, what's up people, Mr. Highway here. Today I continue my video series on O-Level A-Maths Paper 2 2020, and now we are at question 3, binomial distribution, binomial probability, binomial theorem. By considering the general term in the binomial expansion of 3 over x squared plus x to the power of 8, explain why every term is independent of x. Okay, I tell you what. Students are scared to death on explain questions. Okay, they hate it. Like, I know how you feel. You hate explain questions. Okay, that's how all my students feel. If the question tells you to do calculations, it's not so bad. If the question tells you to explain, there are so many ways to explain, right? And sometimes you're afraid that you can't find the right words to describe, and you get marked down for it. Okay, I know it's irritating, but okay, let's see how I did it. To start off, the question already says by considering the general term. So let's go for the general term. The general term, n choose r, a to the power of n minus r, b to the power of r, right? So this is your a, 3 over x squared. This is your b, x. So I sub that in, we get this expression here. The next thing I do is to separate them out. So your binomial coefficient and the base 3 to the power of 8 minus r, I'll put these two together. Why? Because this would be the coefficient part of every term, isn't it? Okay, you just need to sub in the r value. You'll be able to find what the coefficient is. And then we have this part here, which is made up of all the parts with base x. So you have x to the power of negative 2 times 8 minus r plus r, because laws of indices. So we have the general term over here. Now, very simple. The next thing we look at would be, why is every term dependent on x? Okay, now this is where the twist comes in. It's actually just a very slight twist in the question. I don't see any question phrased like this talking about term dependent on x. Well, we learned about terms independent of x. That means in this term, it's just a constant term. There is no x to the power of something. Okay, or you can say that it's x to the power of 0. So we set this up, term independent of x. If you understand what term independent of x is, then you understand what term dependent on x is. It's the opposite, isn't it? Let's go for the term independent of x first. You have x to the power of 16 plus 3r is equals to x to the power of 0. That means this power here is equals to 0. And you realize that r has to be 16 over 3. But r, always takes on integer values. So in this case, there's no way that r can be 16 over 3, isn't it? And therefore, there isn't a term that is independent of x. Okay? So I explain here, since r is not an integer value for x to the power of 0, every term is, in this expansion, is dependent on x. Part 2, find the term independent of x in the expansion of this. So if you remember part 1, this is a continuation of it. It's the exact same thing we have here and the previous part, isn't it? And we already have the general term, so we're going to put it to use now. I put it here. Okay. Now, how is it that earlier on every term is dependent on x? That means there's no term that is independent of x. But now we have a term independent of x. Well, because this part that we got earlier on in part 1 now multiplies by 5 minus 2x, isn't it? So I'll take this, multiply by 5 minus 2x. Okay? Then you think, how is it that you can get a term that is independent of x? It's just a 1 over x term. Okay? The 1 over x term will multiply by the x term to get a term that is independent of x. Now, how about a constant here times the constant here? Well, in part 1, we already say that there is no term independent of x. So there isn't a constant term in this expansion. So no such thing, okay? We have this, we have the 1 over x term, so let's find out what that is. I didn't write this correctly. I meant to say that the power of x is equals to negative 1, okay? So that means this 3r minus 16 would give us a negative 1, and in which case r would be equals to 5. And so if r is 5, then I'll just sub the 5 in here, okay? And then we multiply this whole chunk by 2x. We get negative of 3024. Okay, by the time I started on this question 3, it was 2 hours and 9 minutes by the time I finished this, it was 2 hours and 3 minutes. So I basically took 6 minutes to finish these two parts. Yeah, I did this in 6 minutes, okay? If you think this is fast, well, that's the thing about O-level A Math. You have to be fast. You have to be fast so that you can have time for questions that you get stuck in, so that you can have time for checking. Okay, actually, you shouldn't even be stuck in any question. If that happened to you, then the probability of getting A decreases, right? And there's greater risk now that you might miss A1. You will have to spend time to check. Okay, you can definitely expect mistakes here and there, some really, really stupid ones like what I did in question 2. The link is here, you can go and check it out. So yeah, that's what you're up against if you want to get A1. So like and subscribe. I'll see you in the next video for question 4.